integer. Hi. There are a lot of applications of Euclid's division lemma in number theory. For example, Euclid's division lemma can be applied to prove mathematical relationships such as any positive even integer will be of the form 2m and a positive odd integer will be of the form 2n plus 1 for some integer m. Or for instance, I say that the sum, difference and the product of two even integers will be even. You know these things and you can prove it. Though Euclid's division lemma can also be applied to prove these mathematical relationships. Let's pick one quick example on that. Let's talk about this. Using Euclid's division lemma, prove that square of any positive integer will be of the form 3m or 3m plus 1 for some integer m. Now here we have to use Euclid's division lemma, so let's write it down. Now in this, we gonna be assuming a to be any positive integer and let us say b is 3. We usually assume the value of b either to be the number being given over here or one of its factors. Now based on Euclid's division lemma, we can write a as 3q plus r, where q has to be greater than or equal to 0. Now in this case, r can be either 0 or 1 or 2. Why? Because r has to be greater than or equal to 0 or less than b, wherein here b is 3 as you know. Therefore, we can say a can be either 3q or 3q plus 1 or 3q plus 2. Now based on the question, let's square this positive integer a. So if I square a, we'll get 3q whole squared or 3q plus 1 whole squared or 3q plus 2 whole squared. Let's expand the bracket. First one will be 9q squared. Second one will be 9q squared plus 6q plus 1. And third one will be 9q squared plus 12q plus 4. Now let's reshuffle this and arrange it in such a form like this. Here, let me replace each of these brackets by positive integers k1, k2 and k3 in this manner. If you observe very keenly, over here we have actually proved that a square can be either of the form 3m or 3m plus 1. So this is how you can use Euclid's division lemma to prove such mathematical relationships.